According to the Pareto principle, 80% of results come from 20% of efforts. In this video, I'll share that critical 20% of Git commands that allow you to work from command line whether you're on Windows or any Unix-based system. All you need is a command line application, be it terminal, command prompt, or PowerShell. When I started my IT career 15 years ago, version control systems weren't treated as a separate subject like programming languages, such as C#, Java, or Python. Instead, they were just another tool we used on the job. Back then, many developers relied on UI-based clients to work with Git, Mercurial, or SVN. As a result, we often used version control systems more intuitively rather than understanding what was happening behind the scenes. In this video, I'll share with you a few commands which help me understand Git much better and use it across all platforms I have ever used. This video is aimed mostly at beginners, students, or someone who's just starting their career in programming. It also may be helpful for those who have always used Git only via UI-based clients and doesn't know how commands translate to the command line. Before we proceed, let me explain you a few essential Git concepts. Git is the most popular version control system. Its main job is to track changes in your files and share the changes with your development team through a central repository, often called the remote. In Git you work with two repositories, a local one on your computer and a remote one on a server. Your main task is to sync changes between these two. This involves two key workflows: sending your changes to the remote and updating your local repo with the changes from the remote. Let's review both. Git requires you to explicitly mark the changes you want to commit. This is called staging, and this is step number 1. Once changes are staged, you can commit them. A commit is a snapshot which describes your changes. Commits form a chain that represents your project's history, so you can always go back to a previous state if needed. After creating a commit, you push it to the remote to ensure your updates are shared with the team. Pushing sends your local commits to the remote repository. This allows others to pull your updates into their local copies. Now let's see the steps in action. There are a few popular Git platforms which allow you maintaining your repositories for free, one of which is GitHub, and here we can create a repository and specify its name and gitignore file. In our example, I'll use Visual Studio. After a repository is created, we can copy its URL and then clone it using git clone command and by specifying repository URI. I've just cloned a Git repository, which means that I've created a local copy on my laptop. Now I'm inside the project folder and it's pretty empty for now. It has only one gitignore file. So let's create some project, and I'm gonna create C# web API application. So now, when we have a C# project created inside a Git repo, the first command you'll often use is git status. This command confirms you are in a Git repository, shows which branch you are on, and lists any changes, whether they are staged or not. We'll cover branches later. For now, let's push our changes to the remote. So you see, we have some untracked files, which is basically all source files of the web API C# project we just created. Let's stage these changes. Staging is done with git add command. You can add files individually, but most projects include gitignore files that tells Git which files to ignore, like binaries, cache, or temporary files. And with the proper gitignore, you can stage all the changes with a simple flag all. So git add all command, where all flag means to stage all changes, except those are in the ignored list. Now run git status again, and you can see these all new files that have been added to the stage. So the next step is to commit your changes. A commit saves a snapshot of your project along with message that describes the change. This message helps you and your team understand what each commit does without comparing files line by line. Use git commit m command. After committing, you'll notice that your branch is ahead of the remote, and to update the remote branch, we need to push changes with git push origin main, where origin is the default name of the remote and main is the name of the default branch. Let me do one simple random change to show you a shortcut to stage and commit your changes all at once. It's just one command. This is done with additional a flag to your git commit command. So git commit am and message for the commit, essentially put in changes to stage and immediately commit them with a specific commit command. Once you have commits, you can review the history with git log. This command shows all commits with the hashcode, messages, timestamps, and authors. You can use hashcode to move between commits using git checkout command. For example, if you need to roll back to an earlier state before you added new files, you would use that command, git checkout and commit hash. If you've made experimental or mistaken changes and you want to discard them, just run git checkout --dot. This command reverts all changes in your working directory. Instead of the dot, you can list specific files if you only want to revert those. This step is often used before merging branches to avoid conflicts, of course when you are sure that your changes can be discarded. Another handy command is to delete untracked files you don't want to appear in your repository. It's done with git clean fdx command, where fdx flags force git to remove all untracked files and directories, including those normally ignored. Before pulling updates from the remote, let's cover Git's merge concept. Merging combines the latest commit from your current branch with commits from another branch. That brings us to the branches concept in Git. Git's commit history can form a tree structure. By default, you start with one branch called main. A branch is simply a pointer to a commit, letting you add new commits without changing the main branch. Using branches in Git is common practice. The trivial example is integrating new features into your project. You don't want to affect the main branch where all stable functionalities reside, while you're still working on a feature which may be not properly tested yet. Okay, so you can create a separate branch with git branch and branch name command. As we discussed earlier, to switch to the specific commit, we can use git checkout command. And as branches are essentially just named git commits, the same command applies here. So once a branch is created, we can call git checkout and specify branch name to switch to this newly created branch. You can also create branch and switch to it in one step using the same git checkout command with additional b flag, which tells git to create a new branch before switching to it. Now it becomes clear what is a merge and why it's needed. Git merge command is merging commits of the specific branch to the branch you currently stay on. For example, if you stay on the main branch, the command git merge with the flag noff and branch name will merge the feature branch into the main branch. It means that all content of the merged branch will appear in the main. noff flag prevents a fast forward merge, ensuring that Git creates a merge commit. This merge commit records a snapshot of changes and preserves the branch in history, which can be quite helpful when reviewing your project history with Git log. So after we did the merge and call git status, we can see the new commit is created. The last thing to mention is that git branch or git status commands both could be used to verify on which branch you currently stay. To update your local repo with changes from the remote, you can start with the git fetch command, git fetch origin. This downloads all commits and branches from the remote, which is named origin by default. It downloads this to your local repo, and you can fetch updates for a specific branch too by specifying branch name, so git fetch origin and branch name. Note that fetching only downloads the changes. To incorporate them into your current branch, you'll need to merge, as we discussed earlier. To simplify that process, you can just use git pull, which combines fetching and merging in one step. For example, git pull origin main, this command fetches all new commits from the remote and automatically merges them with your local branch. And that's it for today. We've covered the full Git cycle from managing your local files to pushing changes to the remote and pulling updates back. This covers the most essential Git workflows. Sometimes though, things won't go as planned and you might face merge conflicts. These issues often come from miscommunication in the team and development process challenges. The good news is Git allows you easily fix any mistake. If something has ever been committed, you can always go back to the previous state. Nothing is ever truly lost. Advanced commands like rebase, revert or cherry pick may appear more tricky, but in fact they are all based on the same baseline concepts that we discussed in this video. So if you set up your development process right, chances are you won't ever need anything beyond these baseline commands. In my upcoming videos, I hope to share with you some practices which allowed me to manage teams and set up development processes the way to avoid using tricky Git workflows. You've been watching IT Lunch channel. Have a great and productive day and stay tuned. Bye.